All right, this is 1.1 functions part 2. We're going to be talking about evaluating functions and piecewise functions in this section. So a little bit quickly about function notation. So here's an example function. F of x is equal to 3x plus 1. The letter here is the name of the function. F is a pretty common one, but you'll also see like G or H, or really it could be any letter there. These are some pretty common ones though. X, that's the input variable. X is a pretty common one. T will also be a pretty common one. Mostly we'll be using X though. And then here we have, this has a few different names. Here it's called the output, but it could also be called the function rule. It's what you're doing to the input, which in this case would be multiplying it by 3 and then adding 1. Here's a couple different types of questions you could be asked in function notation. Here, this is telling us to put in the number 5 into the function f and calculate an output, whereas this one is saying the output is equal to negative 14, and we could figure out what value of x would give us that, right? We could just set our function rule equal to negative 14 and then figure out what x value solves that. So, well, this one here was 3 times 5 plus 1, right? Plugging in the number 5 as the input and then getting an output. Anyway, I'm not going to finish those out. I think you can kind of get that idea. Feel free to pause it and do so if you'd like. All righty, moving forward. Again, we're going to be talking about evaluating functions first. So here's a function f of x, x squared plus 3x minus 1. And here's kind of a cutesy way of thinking about it. You can plug anything you want into that function. It can be a number, it could be a heart, which is a little silly, but it could be anything. It could be a variable expression, right? I could plug in, I don't know, x minus 10 in there. Or I could plug in another function. If I had a different function, I could plug in g of x inside of it. There's so much that I can do. I just have to be very careful while doing some of these things and making sure that I substitute it in correctly as an input. We'll go through that. All right, so we're going to go ahead and evaluate these two functions here. We have f of x is equal to the square root of x minus 3. Pretty simple here. We're going to be plugging in 4 for x. And then here we're going to do something a little more complicated. We're going to plug in the expression x plus 7. So anyway, something I like to do is just kind of rewrite the function kind of itself, but leave a blank spot where the variable was. You can leave parentheses. You can do whatever with this. So, and then I'm going to substitute in the number 4. That's it. Pretty simple. Nothing to do inside these parentheses, so I can just go ahead and do the subtraction, right? 4 minus 3 is 1. The square root of 1 is 1. So we get 1 as the output here. Pretty simple. All right, a little more complicated. Not too bad, though. We're going to plug in the expression x plus 7. So that means where the x is, we're going to be replacing it with x plus 7. One thing, when you are putting in an expression like this or a whole other function or something like that, make sure you use parentheses. Group that whole thing together and replace the x with it. That wouldn't matter so much in this case, but it will make a huge difference other times. So make sure you do that. Anyway, nothing I can do inside of these parentheses, nothing that's really being done to it. So I just need to subtract 3 away from it. 7 minus 3 is 4. So we end up with a square root of x plus 4. And that's it. X is still going to be involved here. I'm not getting an output. I'm really kind of getting a new function that was built by putting in this expression there. All right, moving forward, we have slightly more complicated expression here on the right-hand side. This rule is a little more complicated, but same idea. We're first going to be replacing x with negative 8. So we'll go ahead and do that. So negative 8 squared plus 4 times negative 8, and then plus 3. Just make sure you're following order of operations, simplifying this appropriately, but it should be pretty straightforward, right? 64. 4 times negative 8, that's 32, plus 3. That's going to be 32 plus 3, which is 35. So we get 35 is our output. A little bit more complicated here. Let's go ahead and see what happens. Again, we're plugging in a variable expression, so make sure we use parentheses with this. And then again, just simplify this down. Do your best here. Make sure you're not, so we're going to do x minus 2 squared. Remember, that means to multiply it by itself. That's x minus 2 times x minus 2, which is going to give us x squared minus 4x plus 4. Then here we'll need to distribute. So that's going to be plus 4x minus 8, and then plus 3. Combine like terms. Actually, we have a minus 4x and plus 4x. Let's cancel out. So it's going to be x squared. 4 minus 8 is negative 4. Plus 3, that's actually negative 1. So we end up getting x squared minus 1. A little bit of algebra in there. Make sure you can simplify something out like this, right? I kind of did that pretty quickly. Technically, make sure you're doing this sort of double distributing or foiling. X squared minus 2x plus 4. Those two minus 2x's combined to give me that. Anyway. All right, let's keep moving forward. Here's another function. We're going to go ahead and evaluate it. This here is what we call rational function. It's fraction. We have technically this is a polynomial on top, even though it's just constant. And then right here, this is a quadratic on the bottom. I'm going to plug in 0. We have 1 over 0 squared plus 2 times 0 minus 15. 0 is great input because a lot of calculations with 0 are pretty simple. 0 squared is 0 plus 2 times 0 is 0. We just get 1 over negative 15, which actually is just negative 1/15. Pretty simple there. 0 is a great input. Another thing to keep in mind is technically what we actually found here is the y-intercept, because when x is 0, when your input is 0, the output is where the graph of this function would cross the y-axis. Convenient sometimes. And then we'll go ahead and plug this one in here, negative 5. 1 over negative 5 squared plus 2 times negative 5 minus 15. That's going to be 25 minus 10 minus 15. And actually, we have a bit of a problem here. When I combine all this together, I get 0. 0 is not a problem, except where it's located, right? We actually end up getting 1 over 0. Can't do that, can't divide by 0. So actually, technically, this is undefined. The function that we have here is not defined for an input of negative 5. We'll talk a little bit more about that in the future. And then finally, we're evaluating this function, but we have a little bit more going on. This negative 2 here on the outside is being multiplied by the function. So we're going to do negative 2 times this whole thing. Whatever we end up doing, we're going to multiply the whole thing by negative 2. And then right here, this is just telling us to input this expression, x minus 5 in place of x, our input variable. So we'll go ahead and do that pretty quickly. Feel free to pause at any moment and kind of try this on your own. I'm going to go somewhat quickly through this. Okay. I'm going to just simplify the denominator first. Okay, x squared. It's here. That's going to be minus 8x, and then 25 minus 10 minus 15. That's actually 0. So we have negative 2 times 1 over x squared minus 8x. We can go ahead and multiply this negative 2 in. So we'll do that. really just changes the denominator, doesn't really do much else. Or sorry, denominator, the numerator doesn't really do much else. There we go. Seems a little complicated. You know, it's not too bad. We're kind of doing what we've done before, plugging in something in for the x variables, make sure we use parentheses, simplify that down appropriately. Yeah. And we'll clear and move forward. All right, last thing in this section, we're going to talk about piecewise functions. So I have this nice picture of Frankenstein over here. I like to think about these piecewise functions as sort of Frankensteins. They take, you know, parts of one function and another function, and we put them together and to create this kind of Frankenstein monster of an equation. So a piecewise function is defined by multiple equations that are only applied on non-overlapping intervals of the domain. Sounds complicated. Looks complicated too, honestly. Really what we have here is we have three distinct parts. We have this function here and this here. This we'll call the first part. We have this one down here in the second part. And we finally have this third one down here. The third part. These are our three pieces. So the first piece is this equation, f of t is equal to t squared minus 5t. Not too complicated when we think about it like that. Comma, t is less than or equal to negative 10. What this part here is telling us is when should we use this piece? We should use this piece when we're inputting numbers for t that are less than or equal to negative 10. That's the only time we should use this. So for instance, if we were plugging in the number, I don't know, t equals negative 20, use this piece because that number is less than negative 10. Right? Pretty simple there. The middle piece kind of picks up where this one left off, starting at negative 10, not including it, not including negative 10, because negative 10 would actually be included in this piece, but you know, negative 9, all the way up to negative 2. Again, not including, you have to pay attention to these inequality symbols and whether these values are included or not. In this case, negative 2 is not included. It's strictly less than negative 2. So between negative 10 and negative 2, we would use this second piece right here. So pretty simple function, f of t equals t plus 9, 19. And then finally, so for instance, if we were trying to evaluate t of negative 5, we're trying to evaluate negative 5 for this function that falls inside of this interval here. So we would use this middle function. And then finally, we have our third piece, t cubed over t plus 9. We're supposed to use that when t is greater than or equal to negative 2. So if it was negative 2, for t equals negative 2, we would use this one because equal to negative 2 is an option, or anything bigger, we'd use this function down here. So it's kind of this complicated thing, but turns out piecewise functions model a lot of real world problems. Yeah, that's it. We'll go ahead and move forward and kind of do a couple examples. All right, so we're going to evaluate this piecewise function. This one's a little simpler than the one we looked at. F of x is equal to 5x plus 6 for x less than or equal to negative 2. And then f of x is equal to this for x greater than 1, greater than or equal to 1. This one's a little bit weird because this doesn't cover everything, being less than negative 2. Oops, did not mean to do that. Being less than negative 2, so let's just make a quick number line here. And then 1, and our 1's over here, right? So being less than or equal to negative 2, that covers this section here, you know, all the way to negative infinity. And being greater than or equal to 1, all the way up to positive infinity, you know, that covers a lot of numbers, most of the numbers, but there's a substantial gap here in the middle. Technically, not all inputs are valid for this function. Some are going to be undefined. Anything between negative 2 and 1, not including those numbers, would be undefined. So anyway, for f of negative 5, we should use this first piece because negative 5 is less than or equal to negative 2. So we'll use this one. We input that in there. And we're going to calculate an output. Negative 25 plus 6, that is negative 19. That would be our output. Easy. Second one, f of 0. 0 is right here, right? 0. 0 is in the section we just talked about. It's undefined. Doesn't fit into this piece, doesn't fit into this piece. So technically, this piecewise function is undefined as 0. It's not allowed as an input. That's kind of weird, but it can happen. And f of 1. So inputting the number 1 specifically, that falls in this piece. 1 is equal to 1, so we do there. Put in 1 for x. 1 minus 3 is negative 2. Negative 2 squared is 4. Stick that negative on it, we get negative 4. There we go. We're going to do one more example of this. Feel free to pause the video and try this on your own. Okay. F of 2. So is 2 less than negative 3? No, doesn't fit that piece. Is 2 between negative 3 and 2, including 2? Yes. Okay. Fits in this piece right here. It's actually strictly right on that endpoint line there, but it does fit into this piece. So we'll be using this function, negative x minus 4. So that's negative 2 minus 4. We get an output of negative 6. Second one, f of negative 6. Negative 6 fits into this first piece. It is less than negative 3. So we're going to use this first function here. That's negative 2 times x, which is negative 6. That's 4. Negative 2 times negative 6, 12 minus 4, we get 8. And finally, f of 8. 8 is not less than negative 3. 8 is not between these two numbers, but it is greater than 2. So we're going to use this piece. Evaluating that, that's going to be 5. 5 squared is 25. So get negative 25. There we go. Okay. Last thing here, we're going to evaluate a piecewise function on a graph. Doesn't really change much. You know, the x's are the inputs, the y's are the outputs. So let's go ahead and go through this. Our function is v of h. It's defined by this graph. So every point is an input and an output pair. So v of 2 means that 2 is our x, our input, right? So here is 2. One thing you're going to notice as you're looking at this graph, you're going to see these open circles and closed circles like this. An open circle means the graph is not defined at that dot. So this middle piece right here, this graph is not defined on this endpoint right there at 2, but it is defined at this closed dot right there. So for this one, our point being 2, negative 3. So when we input 2, we get out negative 3. That's our output. Second one here, v of negative 3, again, that is our x, our input. So we go over here, negative 3. Don't know why I did that. I think I meant this to be negative 2. That makes way more sense. So let's just do that. Negative 2. We have to go up here to find a point that matches that. It's right there. This point is negative 2, 4. So our output is 4. Last question, a little bit backwards. V of h. So what input gives us an output of negative 1? Outputs are y's, so negative 1 is here. Turns out there are 2 points here, right? Both of these points could be solutions for this. So one of them, very easy, h equals 1. That one's nice, right on the grid line, pretty easy. The second one actually is going to have to take some approximating, hard to tell, pretty close to maybe 3.5. We'll just call it 3.5. If we had, you know, a graphing program or something where you could get that, we would use it, but we'll just approximate there. So there we go. A little bit different, kind of asking us in the opposite direction, but all right. And that's the end of part 2. See you guys in part 3.